Hi everyone, welcome back to Tech-Bimba channel. In the previous video, I talked about lock interface. In the today's video, we will dive into ReentrantLock. ReentrantLock is the class that implements the lock interface. It is present in java.util.concurrent.locks.reentrantLock package. ReentrantLock overrides the methods present in the lock interface such as a lock, unlock, tryLock with a timeout. With a code example, we will see how to use the ReentrantLock and its methods one by one. This is our first example. Here we are having a class with a name counter with instance variable count set to 0. Within increment method, we are doing count plus plus. This count plus plus is not atomic in nature. Internally, it happens in a 3-step process. First value of a count will be read from the memory, then count equal to count plus 1 will happen. Finally, the updated value will be returned back to the memory. This is our main method within which we are creating the instance of the counter class. Then we have a runnable interface reference that is task. This runnable interface has a method run. We are providing the implementation to the run method using the lambda expression. So here we are having a for loop that is running 3 times. Within each iteration, we are calling the increment method on top of the counter class instance. Then we have a thread 1 and a thread 2. Both the threads accept the task as a parameter here. This task is nothing but a reference of the runnable. This is how thread 1 and thread 2 are sharing the counter class instance. We are starting thread 1 and a thread 2. Since we have a t1.join and a t2.join, main thread will wait until t1 and t2 completes their execution. At the line number 66, we are printing the value of a count. So if you notice here, both the thread 1 and thread 2 will execute this for loop. Within each iteration, we are calling the increment method. So t1 and t2 ends up calling increment method 3 times each, because of which the expected output of the count is 6 here. To get the expected output, increment method has to be thread safe. Otherwise, we won't be getting the expected output. Reason is this count plus plus is not atomic in nature. Let's say this increment method is not thread safe and thread T1 got a CPU life cycle. So T1 will start executing the increment method. Control comes to count plus plus. This count plus plus is not atomic in nature. Internally, it happens in a 3-step process. Value of a count will be read from the memory, which is 0. Then count equal to count plus 1 will happen. So now value of a count is 1. Now before writing this updated value to the memory, let's say context switching happens and the thread T2 got a CPU life cycle. Thread T2 will start executing the increment method. So once it will start count plus plus, this statement will be executed, right? That time thread T2 is not aware that thread 1 already updated the value of a count. So it read the value of a count from the memory. Then count equal to count plus 1 will happen. Finally, the updated value will be returned back to the memory. Let's say thread T1 gets the CPU life cycle. It will start from wherever it has left out. So it has already updated the value of a count. That will be returned back to the memory. So if you notice here we are missing the one counter. Thread 1 and thread 2 are racing with each other to increment the value of a count, because of which we might get the undesired output here. So to solve this problem, right, increment method has to be a thread safe. One solution is we can make this method as a synchronized. If you make this method as a synchronized, JVM ensures that at any point of a time only one thread will be able to execute this method. So JVM will basically acquire the monitor lock on the counter class, counter class object, that is C, and at any one point of a time that monitor lock will be allocated to one thread at a time. This is how we are making a increment method as a thread safe. In this example, we are achieving the thread safety using the ReentrantLock. Okay. Here you can notice that we are created the object of the ReentrantLock. Within increment method, we are calling the lock method explicitly. Let's say thread T1 got a CPU life cycle and it will start executing this increment method. At the line number 12, we are basically calling the lock method on top of the lock obj. This lock obj is the object of a reentrant lock. So this lock method will check whether the lock is available on lock obj. In case it is available, the lock will be acquired on the lock obj. If not, thread will go to blocking state. In this case, lock is available, so thread 1 acquired the lock, then it will proceed executing the critical section. Okay, this is our critical section. So once the control will come to count plus plus, it is not atomic in nature, so value of a count will be read from the memory, which is 0 now. So count equal to count plus 1 will happen. Now before writing this updated value to the memory, let's say thread T2 got a CPU life cycle. Thread T2 will start executing increment method. At the line number 12, we are having a lock obj.lock, because of which thread T2 will check whether the lock on the lock obj is available or not. In this case, it is not available. Still, thread 1 is the one that holds the lock of this object, because of which thread T2 will go to blocking state. Once the context switching will happen, thread 1 again gets the CPU life cycle. It will start from wherever it has left out. So it already updated the value of a count, right? So that will be returned back to the memory. Now thread 1 is done with executing the critical section of the code. Now it has to release the lock. So that we are doing in the final section. If you notice here, we are explicitly calling the unlock method on top of the lock obj. So this unlock method will release the lock acquired by thread 1 on the lock obj. Now once the thread T2 gets the CPU cycle, it will able to acquire the lock on the lock obj. Okay, and it will execute this count plus plus. This is how at any one point of a time, only one thread will be able to execute this critical section of the code, and this is how increment method is a thread safe in nature. And one more thing you can notice here, in case of a synchronization, we no need to basically call the lock method explicitly. That will be taken care by the JVM itself. Whereas in case of a reentrant lock, here we have to explicitly call lock and unlock method explicitly. Here basically Java developers are providing the more granular level of acquiring the lock and releasing the lock. And also we can see that in case of a synchronization, we are supposed to acquire the lock on this counter itself, whereas in case of here we are created the object of the reentrant lock. Okay, now let's execute and see whether we are going to get the expected output or not. So we can see that final value of a count is 6. So it doesn't matter which thread got a CPU cycle and which thread is updating the value of a count at that time. At the end, the expected value of a count is 6. So this is possible because here we are using the reentrant lock, using which we are ensuring that increment method is a thread safe. So hope this is clear how we are using the reentrant lock and ensuring the thread safety of the increment method. This is our next example. Here we can see that how reentrant lock allows thread to acquire a lock multiple times. We have a class with the name reentrant lock acquired multiple times. Then we have a method A and a method B. Within the main method, we are creating the instance of the reentrant lock acquired multiple times. Then we have created a thread T1. So thread T1 ends up calling the method A on the object we have created earlier. Okay, then we are starting the thread T1. Once a thread T1 will get the CPU cycle, so it will start executing the method A. At the line number 11, we are calling the lock method on top of the lock obj. This lock obj is the instance of the reentrant lock. So T1 will acquire the lock on the lock obj and it will start executing this critical section. At the line number 18, we are calling the method B. Now control will come to method B. At the line number 29, we can see that again there is a call to lock method on top of the lock obj. But T1 already has a lock on top of the lock obj. But it is completely fine. It will work without any issues. How it works is Internally, reentrant lock maintains a counter. On calling the lock, it will be incremented by 1. On calling the unlock, it will be decremented by 1. So at the line number 11, we are calling the lock. So counter will be incremented to 1. So the value of a counter is now 1. So at the method B, at the line number 29, we are calling the lock method again. So now counter will be incremented by 1 again. So value of a counter will be 2 now. So with this one, thread T1 will acquire the lock again and it will start executing this critical section. Once thread T1 is done with executing this critical section, at the finally block, we can see that we are calling the unlock. So now the counter will be decremented by 1. So value of a counter will be now 1. Now control is finished executing the method B. So it will return to method A. At the method A, in a finally we are calling the unlock, again counter will be decremented by 1. So now value of a counter will be 0. This is how reentrant lock allowing thread to acquire a lock multiple times. Now if you execute this program and see, we can see that thread 0 acquired a lock in method A. So we are getting this line. Then the same thread is acquired a lock in method B. In this example, I will talk about tryLock. What tryLock will do is, in case lock is available, thread will acquire that one and it will return a true. In case lock is not available, this tryLock will return false and thread will not go to indefinite blocking state. To give a real world example, we often use the UPI applications like a GPay, PhonePe for making a transaction. Let's say there are two persons, person A and person B. Person A is making a payment to the person B using a Google Pay. So he initiated the transaction, but maybe because of a network latency, he is not receiving any notification from the application he is using. In that case, person A might think that payment has failed. He will initiate the one more thread for the same transaction. In this case, what should ideally happen here is the thread 2 has to check the status of the earlier transaction. In case it is still in progress, it should return a message to the user mentioning that payment is still in a progress. He has to wait. I try to simulate the same in this example. We have a class with a name payment service tryLock. Then we have a process payment that accepts payment ID as a parameter. Within a main method, we are creating the instance of payment service tryLock. Then we have created a thread T1. So it's the first attempt that user is making. So once we start this program and once T1 will get a CPU lifecycle, it will start executing this process payment. So at the line number 11, we are calling the tryLock on the lock obj. In this case, lock is free. So thread T1 will acquire the lock. It will return a true value. Then thread T1 will start executing these lines or a critical section. So in a console, we will be able to see this line. To simulate the network latency, I have put this thread.sleep for a 3000 milliseconds, because of which thread T1 will go to timed waiting state. Now, person A will think that payment has not happened, because of which he is initiating one more thread for the same transaction. So thread T2 will come and it will basically check this condition, means it will try to acquire a lock on the lock obj, but lock obj's lock is still with a thread 1. So this tryLock will return a false and thread 2 will not go to indefinite blocking state, because of which this else block will be executed. So here we are printing the name of the thread. So in the console, thread T2 will come and will say that payment already in a progress for the payment ID. Transaction ID is what we are printing here. Let me execute this one and we'll see what output we are going to get. So we can see that T1 got a CPU cycle and T1 started the processing payment for a transaction 101. So since there is a 3-second delay, T2 got a CPU cycle. It tries to acquire the lock, but lock is not free, because of which tryLock return a false value. So whatever the line we are having in the else block, right, that will be printed. So T2 is the name of the thread and a payment already in a progress for a transaction 101 is what we are getting in a console. Once 3 seconds got elapsed and a T1 get a CPU cycle, it will start from wherever it has left out, because of which this line will be printed on the console. We can see that T1 completed payment for TXN 101. This is how tryLock works. Hope this is clear. Building on what we just discussed, now we will take a step further and we will look into tryLock with a timeout. So this is a overloaded method. It takes a time duration and a time minutes as a parameter. Here thread will wait for the specified duration. Once that is elapsed and the lock is available, then tryLock will return a true and it will acquire the lock. In case after the time duration is elapsed, even after that the lock is not available, then tryLock will return a false. Thread won't go to indefinite waiting state. To give a real world example, let's say you walked into the restaurant and you were waiting for the table, but all the tables are full. So then a receptionist might come and he will ask you to wait for another 5 minutes. So after waiting for the 5 minutes, if the table is free, that will be allocated to you. But in case even after waiting for the 5 minutes the table is not free, then you have to leave the place. So I try to simulate the same example over here. We are having a class with a name restaurant tryLock timeout. We have a method reserve table. Then this is our main method. Here we are calling the reserve table within the customer 1 and customer 2 threads. So first we have created the instance of restaurant tryLock timeout. Then we have started two threads, customer 1 and a customer 2. First customer 1 will get a CPU cycle and basically this line will be printed on the console. Customer 1 trying to reserve the table. So at the line number 17 there is a tryLock with a timeout. So customer 1 will wait for a 3 seconds to acquire the lock on this table lock. So in this case he is going to get the lock. So he will acquire that table. Okay, he will get that table. Now he will start having the food. So it will take some time, because of which there is a sleep of a 5 seconds here. In between customer 2 also basically comes and tries to execute the same method. Now we will get the statement saying that one customer 2 trying to reserve the table, but lock is present, but that table is acquired by the customer 1, because of which customer 2 has to wait for a 3 seconds. So even after waiting for the 3 seconds, lock is not available, then customer is going to leave. So we are going to get this line in a console. Let me execute and show you how this is going to work. So we can see that customer 2 got a CPU cycle first. Okay, so we got the statement saying that customer 2 trying to reserve the table, even customer 1 trying to reserve the table, but customer 2 got the table. Okay, so customer 1 waited for a 3 seconds. Even after waiting for the 3 seconds, table is not available to him. Okay, lock is not available, because of which for a customer 1 this line of the code is printed. Customer 1 waited but table not available, so he is leaving. So after 5 seconds, now customer is done with his dinner. Okay, so this line of the code will be printed. Customer 2 finished dining, and then he is basically freeing that table. Okay, so we can see that we are calling the unlock here. This is how tryLock with a timeout works. Hope this is clear to you guys. In this example, we will look into lock interruptibility. Let's say there are a thread T1 and thread T2. They are acquiring the lock using the interruptibility one after the other. Let's say thread T1 will come first and it acquires the lock using the lock interruptibility. On acquiring the lock, it starts executing this critical section of the code. Okay. So in between, we can see that there is a thread.sleep of 5 milliseconds, because of which thread T2 will get a CPU cycle and it will also try to acquire the lock using the lock interruptibility. But since a lock is still with a thread T1, thread T2 will go to waiting state. Now later we decided that thread T2 is taking more time to acquire the lock. We might want to stop that one. So we can stop that thread by calling the interrupt method. So in case thread is waiting for acquiring the lock using the lock interruptibility, we can stop that waiting thread by calling the interrupt method. To give a real world example, let's say we are using the IDs like Eclipse or IntelliJ. Once we open the project, at the background index service will be getting started. That index service will basically helps us to go to particular method definition. Index service requires a project's lock so that it can proceed further. Let's say you just open the project and index service is basically waiting for project's lock, and you change your mind. You might be thinking that you opened the wrong project and you wanted to close that. Okay, now we close that one, but the index service is still waiting to acquire the lock on the project. So at the click of the close, right, that is altogether a new thread. In that one, there should be a flow that we can interrupt the index service also. Otherwise, index service will keep on waiting for the project's lock, and it will drain up the CPU memory and CPU cycles. So in such a cases, lock interruptibility will comes handy, and we can call the interrupt method on the waiting thread so that it can stop, it can give up. I try to simulate the same with this example. We have a class with a name index service. We have a index project. This is our main method. So we have created an instance of the index service. Then there is a thread T1 and thread T2. So both the threads are basically calling the index project method. We have started the T1, then there is a sleep of 1 second. After that we are starting the thread T2. Okay, let's say thread T1 gets a CPU cycle, so it will start executing the index project. Okay, it will print this line. Then we are acquiring the lock by calling the lock interruptibility. So thread T1 will acquire the lock and it will start executing this critical section of the code. So in between there is a thread.sleep, right? Because of which it will give up the CPU cycle. Now thread T2 will acquire the CPU cycle and it will start executing. So it will execute this line. So it will also try to acquire the lock using the lock interruptible, but lock is still with a thread T1. So it will go to blocking state. Now if you see here, from the main method we are calling the t2.interrupt. So on calling the t2.interrupt, thread T2 will give up, so it won't be in a blocking state anymore. Let me execute and demonstrate how it works. Okay, we can see that indexer1 waiting for indexing lock. So indexer1 indexing the project. So first we got this line, indexer1 thread got the CPU cycle, because of which we are able to see this line. Then it got the lock and it started indexing the project, so we got this line. Now because of a thread.sleep, so this thread will go to timed waiting state. Now CPU cycle is given to indexer2. Now indexer2 basically started executing this line. Okay, so because of which we can see indexer2 waiting for indexing the lock. Okay, so since it is going to take more time, we are calling that interrupt method here. Okay, because of which now thread T2 will give up. It won't be in a blocking state. So we will get the interrupted exception indexing cancelled for a thread T2. So we can see that indexer2 indexing cancelled. Okay, so indexer2 is basically give up. It is no more basically waiting for the lock on this lock object. Okay, so once the time elapsed, thread T1 will wake up and it will finish indexing, right? This is how lock interruptibility can be used. Hope this is clear how we have to use this lock interruptibility. In this example, we will talk about one more capability of the ReentrantLock, that is fairness. When a bunch of threads are waiting for the lock, fairness ensures they get the lock in the order they requested or asked for the lock. It's like saying first come first serve. To give a real world example, let's say we are having a ticket booking system and daily only limited seats are available. Let's say only 5 seats are available, and for that 5 seats, user 1, user 2, so up to user 100s are requested for ticket. So once the tickets are opened up, our system has to ensure the users those come first and they are requested the ticket first. For them, ticket has to be confirmed. This is how fairness actually works. I try to simulate the same example over here. We have a class with a name Tatkal booking. Then we have a book ticket method. Within main method, we are creating the instance of Tatkal booking. Using the for loop, we are creating the three instance of a thread. That is, we are creating a three threads. Each thread is calling the book ticket. Okay. So let me execute this one. So we can see that user2 thread basically comes first and it's waiting for the lock first. So it got the lock. Okay. User2 waited for the lock first. So it got the lock and it started booking the ticket. So user2 is completed. After user2, user1 is the thread that is waiting for the lock next. So user1 got the lock and it is also started booking the ticket and user 1 is completed. So after user 1, user 3 arrives next. So user 3 got the lock now. So user 3 started booking a ticket, user 3 completed the booking. So this is how fairness works. To enable the fairness in the reentrant lock constructor, we have to pass true. This is how fairness works. So this is our book ticket. So we are just calling the lock method and this is our critical section. So once the booking is done, we are in a final block, we are releasing the lock by calling the unlock. Hope this is clear how fairness works. So one more thing we can note that so whenever we call the lock method using the lock, so we have to release that lock in the finally only. This ensures that even if you get any exception, we are always releasing the lock on that object. Otherwise, the thread holding the lock will keep on holding that lock, so other threads won't get the chance. Yeah, that's it about the reentrant lock. If you found this video is helpful, please like, share and subscribe to the channel. In the next video, we will talk about read write lock in detail. Thanks for watching.